Good morning to all. Today we are going to see about the topic heat exchanger from the subject heat and mass transfer, and I am A. Shankaranarayanamurthy from the Kamaraj College of Engineering Technology, and I am working as an assistant professor in the Department of Mechanical Engineering. First of all, we want to know about what is a heat exchanger. What is a heat exchanger? A heat exchanger is a device that transfers heat from a hot body to a cold body. It can transfer heat from a cold body to a hot body also, but we have to input some energy, that is like in an air conditioning room, in a refrigerator. In such cases, we have to input some work energy. In natural way, the heat exchanger is a device that transfers heat from a hot fluid to a cold fluid. They are widely used in HVAC systems, that is heating, ventilation and air conditioning systems, and it is used to recover heat energy from power plants and in chemical processing industries, in paper processing industries, paper pulp industries, and in many sugarcane industries. The usage of heat exchangers is widely spread all over the globe. The heat exchangers can be classified into many types. The types that are in our syllabus and that we are going to see about three types, that is parallel flow heat exchanger, counter flow heat exchanger and cross flow heat exchanger. First of all, parallel flow heat exchanger. What is a parallel flow heat exchanger? When both the hot fluid and the cold fluid has the same input region and the same output region, then it is known as a parallel flow heat exchanger. What is a counter flow heat exchanger? When the hot fluid and the cold fluid has opposite ends, that is a hot fluid enters through end number 1, but the cold fluid enters through the end number 2, and both fluids will be unmixed and will be traveling in opposite direction, that is known as counter flow heat exchanger. Cross flow heat exchanger. In a cross flow heat exchanger, the flow will be perpendicular to each other, that is hot fluid will be flowing perpendicular to the cold fluid. Now let us move on to the problem, and we will be looking into the solution of that problem also. A counterflow single pass heat exchanger is used to cool the engine oil from 423 Kelvin to 328 Kelvin with water available at 300 Kelvin as the cooling medium. The specific heat of oil is 2125 joule per kg Kelvin, and the flow rate of cooling water is 2.2 kg per second, and the diameter of the tube is 0.4 meter. The flow rate of oil through the outer tube is 2.4 kg per second. The value of the overall heat transfer coefficient is 240 watt per meter square Kelvin. How long must a heat exchanger be to meet its cooling requirements? So now let us look into the solution. First of all, the solution we can divide it into two parts, that is hot fluid and the cold fluid. The given data can be divided into two parts. We will be using the capital letters for hot fluids and small letters for the cold fluid. Okay. So the T1 will be 423 Kelvin and T2 will be 328 Kelvin, and small t1 will be 300 Kelvin, and we have to find out the small t2. Okay. Now the flow rate, that is mh is equal to 2.2 kg per second. The flow rate of oil through the outer tube is 2.4. So mh will be 2.4 kg per second and mc will be 2.2 kg per second, and the specific heat of hot fluid is 2125 joule per kg Kelvin, and hot specific heat of cold fluid is, since it is on water, it is not given, 4187 joule per kg Kelvin. These values we will be remembering. So these are the given values. And one more thing, the U value, that is universal heat transfer rate, is 240 watt per meter square Kelvin. This is what given as U value. Now let us go into, since three temperatures are given, we can solve the solution by LMTD method, that is logarithmic mean temperature difference methodology. Okay, first we have to find out the T2 value and Q value. We shall find out the T2 and Q value. So let us find out QH. We know that the heat loss by the hot fluid will be equal to the heat loss by heat gain by the cold fluid. So, mH Cph T1 minus T2 will be equal to mc Cpc T2 minus T1. Well, let us equate. When we equate these these things, mH is 2.4 into 2125 to T1 T2 is 423 minus 328 will be equal to mc is 2.2, Cpc is 4187 and T2 minus T1 is T2 minus 300 Kelvin. And when we when we solve this equation, T2 will be equal to 75.6 degrees Celsius, which is 75.6 plus 273, that is 8, 14 and 348 Kelvin. This will be the answer for the T2. And now let us verify for now let us go on for the Q value. Since T2 is known, let us go on for the Q value, that is QH. QH or QC, both will be equal to heat transfer rate. So, mH Cph Tu minus T2, which will be equal to 2.4 2125 473 minus 328. So, this will be 484.10 10 to the power 3 watts. This is the heat transfer rate for the for this problem. Now, let us find out the LMTD method. The LMTD method is Q is equal to UA del T LM. From here we have to find out area. From the area we have to find out pi dl length. We have to find out the length. So, still two more steps are remaining. So, del T LM will be del T LM. For counterflow heat exchanger will be T1 minus T2 minus T2 minus T2 the whole divided by ln of Tu minus T2 by T2 minus T1. So, the del T LM, when we substitute all the values, we will be getting del T LM value as 50.6. Del T LM value will be equal to 50.6 degrees Celsius. So, okay, the second step, the next step will be we will be substituting these values in Q, which is 484 will be equal to U A del T LM. So, 484 into 10 to the power 3, the U value is 240 watt per meter square Kelvin into area into 50.6. So, we can find out the area. When we solve this thing, the area will be 40.2 meter square. Next, since this is an cylindrical surface, the area formula will be A is equal to pi d1 into L. So, 40.2 is equal to pi into d. The d value is given as 0.4 meter. So, into 0.4 into L. So, when we calculate this, L will be equal to 40.2 divided by pi into 0.4. It will be approximately, it will be equal to 18.6 meter square. This is how we have to find out the length of the given heat exchanger. This is the required length of the given heat exchanger. Thank you.